Hello everyone. So, we will continue with measurement of yarn hairiness. So, in our last segment we have discussed the two methods. One is Shardley yarn hairiness tester, another is Zweigel hairiness tester. Now, we will discuss the Worcester hairiness testing system. Okay. So, what we have discussed earlier, in earlier methods we have seen the in Zweigel and Shardley we measure the length of hair protruding above the yarn surface at a certain specific setting, and in Worcester principle it measure the amount of hair scattered, amount of light scattered by hairs. Okay. So, parallel beam of infrared light is illuminated, and if there is no hairs present, or in fact there is, suppose there is no yarn present here, this light, parallel light will be blocked here by the stop arrangement. Okay. These are the stop arrangement, and the light will not reach. Okay. Even the yarn, suppose the yarn there is no hairs, no filament yarn, still in case of filament yarn, so there will not be any light scattering due to hair. So, this light will not reach, that so light will either be blocked by the yarn, or if it goes parallel it will be, and that it will be blocked here. Okay. So, that way that setting is that the size of the block is actually it is equal or little bit higher than the this diameter of this aperture. Okay. Now, if the light there are hairs, so hairs present and these hairs will start scattering the light. So, light will get scattered and will try to move away from the straight path, and all this light that will try to get scattered, and the lights which will come which will be go to this system, light capture system, this light will be scattered, light will get captured and will get transmitted, and ultimately it will be projected through to the receiver. So, this amount of light which receiver is receiving, it's intensity, its quantity which it will receive, it will actually it will be proportional to the number of hairs. So, amount. So, let us see the animation of this principle. So, this is a light source, it is a light when there is no yarn present. So, light is actually falling on this lens, okay, and then it has converted to parallel light, okay, and that actually light will be blocked here with the direct light will be stopped. Okay. This is this light will be stopped here. So, any light it is coming it so the transmit that intensity here light is 0. So, there is no light coming here. When the yarn with no hairs, so there is this is a yarn does not have any hair. So, again the ultimate impact will be the same, because it actually it is not receiving any scattered light. Now, let us see now yarn with large number of hairs coming, okay, and then this light will start, this hairs will start scattering the light which will be beyond this stop mechanism, and then this will be actually through this lens system it will get projected. So, this the amount of light, okay, this is actually proportional to the the length of the hair. Okay. So, indirectly by measuring this intensity we can get idea about the intensity of or length of total length of the hairs. Okay. So, this is the indirect method way of measurement of hairiness. We can get idea about the prickle sensation. Okay. So, this its amount of scattered light is then measured of hairiness. Okay. And we get ultimately a hairiness index. So, total number of length of hair per unit length of yarn, it is a dimensionless. So, we get one index. Okay. So, this is for comparing the values. So, these are the different ways of getting data by way of spectrogram or something. Now, we will discuss the assessment of fabric surface hairiness, okay, to assess the prickliness of fabric. So, this is measured by first method is it by low stress compression mechanism. So, if in the low stress compression measurement technique, if it is compressible at very low stress, that means that will give indirect indication of the hairiness, because normal yarn hairiness, yarn compression is not that it is not that compressible at very low stress. If the fabric is very compressible at low stress, that indirectly gives the idea about the hairiness present at the surface and indirectly gives the prickliness sensation, prickliness characteristics of fabric. Then it is by measurement of counting the protruding fibers of the surface. It is similar to the laser counting of protruding fiber. It is actually similar to Wooster measurement of technique. It is based on light scattering technique, and third is the modified audio pickup method. It gives idea about the buckling force that we will discuss here. Okay. Buckling force and bending force of measurement. Okay. So, if we modify the Kawabata system like KESF 3 compression system, which indirectly gives the low stress low pressure compression testing. So, that from that data at low pressure, if we modify at low pressure, that gives the prickliness sensation indirectly. Okay. So, applied pressure, the relationship between applied pressure and fabric thickness. So, that we can measure. So, when bending of fibers protruding from the surface takes place, okay, during compression. Okay. So, at that time we can get the idea of the hairiness or prickliness by low pressure compression system. And next technique is that it is here an optical system, as we have seen in the Wooster hairiness tester. It counts the fibers protruding from the fabric surface. So, this is the fabric surface, this is the fabric roll, it is the fabric let off, and here is the take up arrangement, and this is the there is a knife edge through which fabric is moving, and whatever the hairs protruding here, these hairs will actually scattered light, and this scattered light will be received by the photoreceptor. So, this is the similar method. An optical hairiness meter monitors the amount of light scattered from the belt of the fabric passed over the sharp bend. This is a sharp bend. Okay. The fabric sample moves continuously at certain speed, okay, and then we measure. So, this technique is similar to the light scattering technique by Wooster, and we get idea about the fabric surface hairiness and indirectly get idea about the prickliness sensation. Okay. Next one is which measures the prickliness sensation directly, which is modified audio pickup technique. It measures the mean force per contact with the protruding fiber. What is the mean force per protruding fiber it measures, which is actually directly gives indication of prickliness sensation. Protruding fibers are there. So, this technique may be the most effective technique of fabric prickliness. Okay. and the result obtained from this instrument actually directly correlate with the subjective perception of the fabric prickle. This is the most actually effective technique for fabric prickleness sensation measurement. Now, this is the instrument. Here this is the block, okay, light block. It is actually connected with the load cell. A normal load you are applying, and here it is a load cell is there, and here a normal load force is applied, and these are the surfaces where it actually these surfaces are used to buckle the protruding fiber. So, the buckling takes place at this point and this point. So, buckling of the fibers take place at this point, and this is the stationary audio stylus which actually sense the bending force. Now, with this arrangement, now if we start moving the fabric, this is the stationary measurement. Now, where we have applied the normal load, then this normal load gives the idea about the this buckling force. So, we can measure the erected hairs are there, projected hair, and if we apply load, so we have the buckling force. So, this gives the buckling force, and when we move the fabric here, it is measured, the force is measured by here the force measuring unit. And how does this force come into picture? This force is coming into picture due to the projected hairs here. This projected hair are due to the bending force of this hair, it gets signal from its audio stylus is there, and ultimately we get measurement of force here. Okay. So, this gives this force unit measuring unit gives the bending force of this hairs. So, we get characteristics. One is as the fabric surface moves under stationary audio stylus, from which the signals are obtained from the contact between stylus and the protruding fiber, that we get some signal of the fabric bending and the buckling of the fabric. So, two classical models are here. One is that loaded cantilever, it is a bending force we measure, and Euler column, that is a buckling. So, which calculates the bending force and critical buckling force. So, these two parameter if we get the idea about the what type of hairs are present. Earlier measurement technique was indirect, where we can only tell that it is a hairs are there, but here we measure the type of hair. If the bending force or buckling force is they are high, so that means we can tell, okay, this particular hair will create problem in prickle sensation. Okay. So, that this type of, and buckling force is extremely important. If the buckling force is less, that means it will not create any problem of prickleness even if there are hairs. So, the critical buckling force of the protruding fiber end is responsible for stimulating mechanoreceptors, that these are the fibers. If it is a high buckling force, that will actually give stimulation to the pain receptors. Okay. So, this is the type of, this is the buckling force Euler column, and this is the loaded cantilever. So, this we get, this is the normal protruding fiber. Okay. And we can see that if the fiber length is more, what will happen? The bending force will be less and buckling force will also be less. If the fiber diameter is more, then we will get higher value. So, we have this critical buckling force we can calculate, we can get this buckling force with the standard formula pi square by multiplied by E is the Young's modulus, I is the moment of inertia, and this L is the length of the protruding fiber. So, this with this equation we can get the critical buckling force, that means higher Young's modulus if we use a fiber with higher Young's modulus, it will give higher critical buckling force. That means, it will give higher prickle sensation. If the moment of its bending rigidity or moment of inertia of the fiber is high, so moment of inertia is actually directly proportional to the diameter of the fiber. That means, if we use coarser fiber, it will give higher buckling force, it will give higher prickle sensation. If we use longer fiber will give the less buckling force. That means, what does it mean? So, it is a combination of Young's modulus, the diameter of fiber and length of fiber. So, if we have coarser fiber and if we use longer length, that means effectively our buckling force will be less. So, it may not give the prickle sensation. The problem of prickle sensation is that if it is short fiber projected and coarser fiber with higher moment of inertia and higher in Young's modulus, and which is actually which if we use a coarser wool fiber, that this coarser wool fiber gives this all this negative behavior, and ultimately we get this prickle sensation. So, if we know all these characteristics, we can design a cloth without prickle sensation. Okay. So, it is clear from this equation that prickliness of fabric is actually related with the Young's modulus, diameter of fiber and length protruding of the fiber. So, they are the key factors of prickliness. So, it as we have discussed, with the increase of Young's modulus, the prickliness increases, with the diameter increase it increases, and with the increase of length it reduces. Okay. Now, these are the what we have discussed, the objective measurement. Now, if we see the subjective measurement techniques, so this is again, if we use the laws of psychophysics that we have discussed, that it is a subjective perception is R S, and the prickle stimulus intensity it is S P. That is, we can you can use the stimulus intensity by the critical buckling force as stimulus intensity, or mean number of fibers, that is more than 75 milligram per 10 square centimeter, this number of fibers also. So, there are a relationship. So, the Stevens psychophysical power law that we have discussed earlier. So, here the exponent B for prickliness sensation, it is typically 0.66. So, what we have seen earlier, for different types of sensations, this exponent is different. Okay. For I think that it is for electric shock we have discussed, it is a 3.5. So, for brightness it was different. Similarly, for prickliness here it is a 0.66. So, that is this is the equation. This we can it is actually with this it is a very closely correlated with the subjective assessment. Okay. So, RS is the subjective response of the prickliness, and it is a prickle stimulus intensity that we have seen, and the correlation coefficient here it is a 0.91, very good correlation is there. So, we can see this is the type of curve where x axis is the prickliness stimulus intensity, and here is the stress sensation of prickliness. Okay. Now, coming to another tactile response which is important, which is called itchiness of the fabric, and this itchiness is directly related, as we have discussed earlier. It is a activity of superficial pain receptors directly related with the fabric prickliness. Okay. This actually these are highly correlated with the prickliness sensation, and the fabric itchiness depends on the fiber diameter as prickleness also depends on this, and the fabric thickness at low and high pressure, that means it is a compressibility. It depends on the compressibility and fabric surface roughness also. So, rough surface will give higher itchiness. Okay. Next is the fabric frictional interaction. Okay. So, these tactile responses are that roughness perception, perception of smoothness and perception of scratchiness, which are directly or indirectly related with the frictional characteristics of fabric. These are dependent on the basically frictional characteristics between fabric and skin. Okay. So, the presence of moisture, when we actually the frictional characteristics is one aspect, but the perception of roughness increases with the increase in moisture content. Okay. So, presence of moisture at the skin surface totally altered the intensity of roughness perception due to change in friction. So, what does it mean? So, normal in dry condition, if we perceive one type of scratchiness or roughness of fabric, if the moisture content in the skin, if we start sweating, its total our perception of roughness will change. So, as the moisture content increases, the friction between skin and fabric surface increases, which results actually with different type of tactile sensation will be there. Suppose in dry condition, when the skin is dry, the fabric will try to slip over the skin surface due to lower friction between skin and fabric, but as it gets wet, it will actually friction is increased. So, it will try to pull the skin. So, which result displacement of skin due to the pull of the fabric. Okay. So, this gives idea, thus the more and more touch receptors are stimulated, we will get totally different type of sensation. Okay. So, due to different receptors. Okay. This is the reason when actually fabric may be comfortable when we are not sweating, but the same fabric will become uncomfortable as far as tactile sensation is concerned when we will start sweating. That means, it actually stimulate other receptors due to pull in the skin. Okay. And this is mainly due to the increase in friction between skin and the cloth due to presence in moisture. So, this is the one study report which shows the coefficient of friction, okay, coefficient of friction between say skin and the cloth, a particular type of cloth at different types of material present. So, when it is a dry, we can see the friction is at this point, this is the friction, okay, at lower level around say 0.4 or something. But when it is a wet, so water is present, okay, the friction has it is highest friction. This is there are theories present, it forms some bond, okay. So, and that it tries to drag the fabric. So, higher friction. So, this higher friction, presence of water or maybe sweat, so it gives higher friction, that actually stimulates different types of sensations. Now, the scratchiness. So, this is another source of discomfort which are related with the frictional interaction. Now, we are discussing the prickleness and friction. So, first we are discussing prickleness and friction. Prickleness we have discussed, friction related aspects we are discussing here, and another way of sensation of friction related aspect is the scratchiness. Okay. So, main source of discomfort, okay, and it is related with the compression, bending and frictional interaction. It is actually common perception that scratchiness actually men are slightly more critical as far as scratchiness is concerned than women in terms of scratchiness and clinginess. Clinginess is another aspect which is related with the frictional delay. So, roughness, scratchiness, clinginess. So, these are related with this frictional characteristics, and the study report shows the men are a little bit more critical. This is nothing but due to that actually it is due to generally men perspire more than women. Okay, that is a general perception, it may not be true. So, due to higher perspiration, higher amount of moisture present in the skin. So, higher frictional interaction, higher scratchiness, higher friction, higher clinginess. Okay. Now, scratchiness main source of discomfort is it's more in hot and humid climate. So, we feel more scratchiness in hot and humid climate. Why? Because it gives more sweat. So, that is why in cold and dry climate we do not feel, normally we do not feel scratchiness, but same fabric we may feel scratchiness. Another observation is that generally fabric from monofilament yarn result high scratchiness than multifilament or staple yarn. That is our general perception and general feeling. If we wear a clothing made of say woven fabric made of monofilament, flat monofilament, I am talking about a flat monofilament, it is not bulked, it is not textured. Flat monofilament fabric if we wear directly on our body and we feel scratchiness sensation, but in case of multifilament or maybe staple or textured we will not feel this type of scratches. So, the reason behind this that it is a basically stick slip nature. Monofilament fabric gives a stick slip nature against the skin, that gives the scratchiness sensation, but for other type of fabric yarn it gives it actually any for any displacement it does not give the stick slip that type of. So, this is the stick slip mechanism and this actually gives the scratchy sensation. Any movement with the stick slip movement it gives scratchiness sensation, which is actually predominant in case of monofilament fabric. So, how to measure the scratchiness sensation objectively? So, the objective measurement of scratchiness is that it is the fabric is passed over a microphone. Okay. Microphone yielded a scratchiness sound. So, fabric one system is there and below the attachment a microphone is placed. So, when fabric is moved there will be, if there is a scratchiness sensation that will give some sound, and depending on the level of sound one can get idea about the scratchiness sensation. So, the fabric was moved at a speed of 7 yards per minute across a brass sheet above a microphone. So, it is placed above a microphone, that brass sheet is placed above microphone and the fabric is moved at a certain speed. So, if there is any roughness or any scratchiness sensation, if there is any stick slip sensation, it will generate some sound and that sound is actually measured. Okay. The signal from microphone was then sent through a amplifier, integrated amplifier, and it records the sound. And there is a good correlation between the subjective measurement of scratchiness by human object and this objective value of scratchiness. So, this there is a very good correlation between this object, and this scratchiness depends on, there are other factors also, that is a diameter of even if it is monofilament, if the diameter is low, like we have produced fiber from microfilament, the scratchiness may be less. it has to be it has to have high bending rigidity. So, a coarse filament will give more scratchiness value. Okay. So, good correlation has been observed. Okay. So, this is the objective measure rating, and here is the subjective rating of scratchiness. Okay. So, there is a good correlation between these two. Now, the what we will discuss is that the fabric handle attributes for expressing the tactile comfort. So, there are various fabric handle attributes. The quality of fabric is generally perceived through tactile sensation. The consumer always first touch the fabric before they buy. So, that this is the tactile aspect which first sense before we actually from there we can get idea about the fabric tactile sensation, and majority of the fabric is rejected even if the fabric is color wise, even size wise, everything design wise it is okay, but if the fabric is tactile sensation is poor, we normally do not purchase because it will give unnecessary discomfort. And there are improvement in. So, in this area the work has been done to improve the finishing, and the fiber characteristics have been improved. There are specialty textile structure has been improved to improve the fabric handle. So, this in this area actually significant development has been done to improve the fabric tactile sensation. Okay. The fabric tactile sensation is actually it's not that simple. Okay. It may be defined as the human tactile response towards fabric, which involves not only physical, but physiological perception and social factors also. Okay. So, this is very complicated. Okay. So, that tactile sensation is not only this fabric related characteristics, but other characteristics are also important, like social factors are also there. Okay. And but we will discuss here only physical factors of the fabric. So, fabric physical factors, perceptual factors are also there, and physiological factors. So, this perception, physiology, social factor, that we have, these things we have discussed earlier. Okay, earlier section. Here we will discuss the physical aspects of tactile sensations, and what are the different measurement. There are, you can measure subjectively or we can measure objectively. So, these aspects we will discuss here. Okay. So, fabric handle and present systems, it can be measured by subjectively by judge, by experienced people from in the industry, that is the present system, and by a physical movement of fabric. So, we can take the fabric sample and do some test quickly with the by hand, and we can judge the idea, get the idea about the fabric's handle or tactile responses, like it is a bending. If we try to bend the fabric by hand, okay, we can get idea about its flexibility. Okay, that is the one way of looking at. Then it is say rubbing. So, if we rub the fabric by our thumb, okay, finger, so that gives an idea about the friction or surface roughness. This idea we can get. So, this is the stretching by, say it is a pressing. If we press the fabric, we get idea about the softness or it is a bulk characteristics we get. Here is the stretching of fabric, we get elasticity or stretchability of fabric, this idea we can get, and this is the it is a shear characteristic, shearing. So, we can get. So, these are the aspects we try to measure when we select a clothing, but this is not enough, because this gives a subjective actually it has got total subjectivity, and we cannot express, we cannot get totality of a fabric. Okay. We can actually select a fabric broadly. Okay. So, we need a measurement technique for this. So, there are techniques available. The techniques we can divide into two aspects. One is subjective measurement of fabric handle or tactile related characteristics, and other is the objective characteristics. First, we will discuss the subjective. What are the subjective ways of measurement of fabric tactile characteristics? The subjective measurement techniques are, its first, traditionally the fabric handle was measured subjectively, and first it has been reported by Binns, okay, in 1926. The physiologically based subjective assessment of fabric handle, it has been reported there. Okay. So, that is psychologically based. So, that it measures the different subjective assessment, and it gives the rating, as we have discussed, different psychological rating it gives. It gets the value. Fabric is judged by the experience judged. So, experience judge, they measure this softness or flexibility and gives the ranking. So, that has been reported in 1926. So, after that by a factor analysis technique in 1958 it has been reported. So, there are different underlying relationship, interrelationship between fabric handle characteristics that is been reported. So, they have isolated three important fabric handle related aspects. So, these are the smoothness of fabric, stiffness and fabric bulk. So, these are the actually the three subjective characteristics of fabric they have identified, and they have, the bulk is directly proportional to the area density and thickness of the fabric. So, they have tried to correlate this subjective assessment with the sensation. Okay. Then psychophysical actually concept has been proposed. This concept from both decision theory and information theory have been used and proposed the 4 different sensory attributes. Okay. These are smoothness, stiffness, bulk property, and also this has been proposed earlier also. Here they have again extra, they have proposed as warmth of the fabric. So, warmness and coolness also gives the direct tactile response of fabric. A fabric may be very good in tactile sensation, if it gives warmth, it gives very warmness. So, then we may feel a little bit discomfort in tactile. So, they have introduced this warmness or coolness. So, we will stop here, we will continue in the next class. Thank you.